Hey, how's it going everyone? Welcome to this video. Today we're just going to have a look at a couple of examples using our exact values for different trig angles. So the first one we're going to have a look at is cos of 5 pi over 3. And there's a couple of different ways we can look at it. 5 pi on 3 is the same as 5/3 of pi, which is the same as 1 whole pi plus um, 2/3 of another. So when we're looking at our unit circle, I've got a full rotation or a full pi plus 2/3 of one. So if I break up the last bit into thirds, 1, 2, 3, I've got two of them. So we're going to be sitting over here. So that would be 5 pi on 3. Now the other option is 5 pi on 3 is the same as 2 pi take pi on 3. So we've got full rotation of 2 pi, but I don't have that much. I've only got 5 pi on 3, so it's just a little bit less. So this angle in here is going to be pi on 3. And from there, I can actually make up a triangle, which will be essentially the same as the one in the first quadrant. So pi on 3 and pi on 3, it's just reflected across the horizontal. And if you have a look at that, it should be a recognizable triangle, pi on 3. So this is one of our exact triangles, where the other angle is pi on 6. We have root 3, 1, and should be a 2. And going back to the actual question, we're looking at 5 pi on 3, cos of 5 pi on 3. So we've just found out that really we're looking at this triangle here, which is our exact triangle. So cos of 5 pi on 3, pi on 3 is 1 over 2. And because we've got symmetry properties, I can say cos of 5 pi on 3 is the same as cos of pi on 3. So because they're both the same, my final answer would be cos of 5 pi on 3 is just simply a half. Now, I didn't check, but just remember our values for positives and negatives. We've got all, sine, tan, and cos. We're in the fourth quadrant, Q4. Cos is positive, so they're both positive, which is good. The next example is sine of 7 pi over 6. Similar to what we've just done there. Alright, I've got 7 pi on 6. Well, that's the same as 2 pi take pi on 6. And pi on 6 is roughly, hopefully you can see that, pi on 6. And that's the same as the symmetry property of reflection in the horizontal. And so if I draw it out a bit bigger, we've got pi on 6. And this length here, that's our exact triangle. So we've got square root of 3, 1, and 2. So because they're basically the same triangle, sine of 7 pi on 6 is going to be the same as sine of pi on 6. Now, this time we do need to check our signs of the sign, I guess, positive, negative. Well, we're in the fourth quadrant over here. Only cos is positive in there. So sine of 7 pi on 6 is actually minus sine of pi on 6. And sine of pi on 6, opposite over hypotenuse, so it's 1 over 2, except it's now negative. The last example, we've got tan of minus 30, and if we draw up our circle, minus 30, again we're in the fourth quadrant there because we're going backwards at 30. So if I draw that triangle up a bit bigger, we have 30 degrees. Well, that's again this triangle here, except now we're in degrees, not radians. The values on the side still don't change. So we get root 3, 1 and 2. Tan of minus 30, well, that's going to be the same as tan of 30, except we're in the fourth quadrant, only cos is positive in there. So that's got to be minus. So minus tan of 30, tan of 30 is 1 over root 3, or root 3 over 3, depending which one you want to use. So, and it's going to be the minus of those. So minus or minus. So that's using the unit circle for symmetry properties for different angles. Essentially the method's the same. We just work out which triangle we're using in terms of symmetry for the first quadrant. And using that and our signs, we can use to determine what values they are. So that's it for this video at the moment. Stay tuned for the next one. We'll go through a couple more examples. Thanks for watching.